Okay, for the 2 quizzes you're doing on your own, I want to just do a quick summary of the study guides. There are basically 4 different new vocabularies and their centers that you have to be familiar with. So let's go see what these 4 things are. In the 2.9, you are going to be looking at the median of a triangle. What is the median? The median goes from the vertex to the midpoint of the opposite side. And that's a line that's drawn between those two. Then you've got the other vertex to the midpoint of the other side. And you've got the final vertex to the midpoint of the other side. How do I know it's a midpoint? Because there's going to be little things drawn here showing you that these are equal. They are not equal to each other. They are just equal. This small 3-line segment is going to be equal to this 3-line segment because this is the midpoint. So what is this center called? This center of a triangle is called a centroid. So the center of your 3 medians where they intersect is called a centroid. Notice that the medians go from a vertex to the midpoint. Of the opposite side. Okay, let's go look at the second vocabulary word, an altitude. An altitude of a triangle does not go to the midpoint of the opposite side, but just forms a 90-degree angle. So this time, when it's going from the vertex to the opposite side, it's not going to a midpoint, it's just going straight down to wherever it lands. So you're going to notice that this center is offset in most cases. So this still goes from a vertex to the opposite side, but it forms a 90-degree angle. It is not a midpoint anymore. The median is the midpoint, M&M. The altitude forms a 90. Now, what is this center called of an altitude? This is called your orthocenter. Okay, let's go look at the next one. So there is a special case when your median is the same as an altitude, and that's only during an isosceles triangle. So when I draw in the median, it's a terrible line, hang on. When I draw in the median of an isosceles, by the way, what's an isosceles? An isosceles is a triangle with 2 of the same equal sides, right? When I draw on the median of this one, I thought I had a line option, hang on. Okay, I don't know where my line option went. Anyways, I'll do my best with my straight line. When we draw in this altitude, when it's an isosceles triangle, it does happen to be also the midpoint of the opposite side. There are going to be 3 questions on your 2.9 quiz that talk to you about this special case. So here's one example. Given that BD is a median and an altitude, the congruence postulate is used to provide this, and it has to do with isosceles. Because you've got this altitude that is a median, the red line in the middle, you want to keep that in mind. Why can we use SAS on that? Because you've got the reflexive side, that is your median and your altitude. You've got the 90-degree angle, which makes these angles equal. And since it's a bisector, since the median is the midpoint, you know that these other sides are also equal. So you basically have a side angle side. Because it's an isosceles, you know that that side angle side applies. We also know that this side is equal in an isosceles. But anyways. Okay, so there's going to be 3 questions on the 2.9 quiz about this special case when the median is the same as the altitude. Now on to the 210. What is an angle bisector? All right, an angle bisector is when this line comes out of the vertex and it splits this angle exactly in half. When this line comes out of this vertex and it splits this angle exactly in half as well. And finally, when this line comes out of the vertex and it splits this angle exactly in half as well, because the angle is being bisected. What is this center called? This center is called and incenter. Okay, next, our last one is a perpendicular bisector. What happens for this one is bisector means you're bisecting the opposite line segment. So this case, for it to be perpendicular, I want you to imagine a line that's forming a 90 and how it is not starting at a vertex this time. Like the other words were, a perpendicular bisector has to form 90, has to split the other side in half, so it's not coming out of a vertex. Let's look at this next one. Here's my midpoint, more or less. I want you to imagine a perpendicular bisector going through that, meaning that it's forming a 90 and it split this in half. And finally, the last one might be right here, where it split this in half and it's forming a 90. So picture this line and how it doesn't come from a vertex. What is the center of these perpendicular bisectors called? The circumcenter. I had a student ask me, how am I supposed to remember that circumcenter goes with perpendicular bisector, and that incenter goes with angle bisector, and that orthocenter goes with the altitude, and that the centroid goes with the median? Well, you just have to memorize those or have these notes handy during the quiz. Finally, I gave you a couple of visuals here at the end in case you need to look at these. Notice here your medians that have the center as a centroid. Notice here your I put these out of order. I'm sorry, you guys. Your altitude that has its orthocenter. Notice here your angle bisector that has its incenter. And notice here your perpendicular bisector that has the circumcenter. Notice that all of these come through a vertex except the perpendicular bisector. When can the median be the same as an altitude? When it's an isosceles triangle. That's the special case. Okay, hope this helps you on the quiz. Good luck.